All right, welcome back, everybody. So you had a chance to play around with the simulation and gotten a sense for what capacitors look like, what they do. I'm just going to go through a bunch of facts about capacitors here, talk a little bit about what they are and what they do. We're going to put these into practice in class on Thursday. So like I said in the previous video, anytime I've got two conductors where I put kind of positive charge on one and negative charge on the other, I've made a capacitor. The simplified model of a capacitor that we will use most of the time is called the parallel plate capacitor, where you just take two plates and put them next to each other, rather than weird shaped pieces of metal. And we choose that because the electric field and the electric potential are both really simple for that example. Of course, if you've got these two pieces of metal with charge on them, you're going to get a potential difference between the two metal plates, which we would say is across the capacitor. And we can actually define a physical property of the system called the capacitance, which is basically how much charge gives you 1 volt of potential difference between them. As you can imagine, for each extra coulomb that you throw on the capacitor, you're going to get a bigger and bigger potential difference. So the capacitance kind of takes into account how much you're getting for each coulomb of charge that you put on there. The capacitance is usually a characteristic of the capacitor's geometry. It's something that depends on how big the plates are, how close they are together. Are they actually flat? Are they actually infinite? That sort of thing. Capacitance is measured in farads. That's just like another unit that's the same as a coulomb per volt. Farads numerically are huge numbers. Usually capacitors are in microfarads or nanofarads or picofarads. They're pretty small. You can get millifarads if you've got like a really big capacitor, like in a big air conditioner or something. In fact, I have a capacitor here. This is a capacitor. It's a real one. It doesn't look very cool because all the secret stuff is in the middle. But this is a capacitor. This is from my fridge, which broke a couple of years ago. And it turns out that this little thing, just this one piece, if this stops working, the fridge doesn't work anymore and you got to get a new one. So that's a good thing to know. These are actually useful little things. They're not just imaginary physics toys.